The central object in the AAI data model is the job stream. It's the active mechanism that mirrors executed processes in the scheduler so as to unlock the benefits promised by AAI: predictive runtime analysis, statistics, averages, SLA management, and more. For any workflow existing in Automic, we can create a matching job stream in AAI. Then, each time the workflow executes in Automic, a corresponding job stream run is generated in AAI. Each of these runs is cataloged and can be analyzed in many different ways, which represents AAI's overall value proposition. You have to remember that when the scheduler connection is created, AAI captures all object definitions, like jobs and workflows, and their sequencing relationships. AAI is immediately aware of their existence, as well as past executions, called events in AAI. This means that AAI has everything it needs: definitions and past executions. It's then up to us, the user, to simply create job streams using this information. The process is really quite simple. We installed AAI in the connector and set up a scheduler connection in the web UI. The successful connection enables AAI, which acquires all the information it needs from Automic's REST API for a given client: all definitions, jobs, workflows, and so forth, as well as the execution history. We saw this in the connector's log. The data is imported in AAI's database, where definitions are normalized as AAI jobs and executions as AAI events. We, as the user, create job streams using this data. This is the process. Let's take a simple Automic workflow. The workflow and component jobs have corresponding definitions in AAI. In order to enable AAI's analytical and reporting capabilities, we create a job stream for this workflow. We identify the last job in the workflow in Automic and find its AAI counterparts. We call this the target job. When the job stream is created, AAI uses the target job to look at all the predecessors to build a complete model of the workflow. AAI also uses the workflow's execution history to generate corresponding job stream runs. We now have the complete picture of the workflow in AAI. We can start analyzing SLAs, critical path, statistics, averages, reporting, alerting, monitoring, and much more. If you select a job which isn't the last, then AAI will perform this analysis just as well. However, it only considers predecessors. Successors are ignored, and so your analysis will be incomplete. Let's start in Automic's process monitoring perspective. We see a number of processes automated with period objects. Let's look at the definitions. We can use any of these workflows, it doesn't matter. Note that some of your workflows are real business processes. They perform tasks against the applications. Other processes might be technical in nature and don't need to be analyzed. They might, for example, support internal sequencing or enforce cross-system orchestration. Job owners won't want to analyze those. And so it's important to understand that we don't need job streams for everything. Developers will want to be selective to focus on the processes that affect their business units directly. This is the workflow. In order to build the job stream, we'll need to know the name of the workflow and target the last job. This will be the target job in AAI, which defines the job stream as a whole. We're in the system monitoring page where we left off. Let's show the jobs page. The jobs page shows all objects acquired when the connection was created. You can see object names. You can also see the scheduler, which should make sense. Remember that if you create multiple scheduler connections, all imported objects are created as jobs in this environment. We see the machine, which is the agent associated with the jobs objects, the parent workflow, current status in Automic, and object type. Let's look at the job stream definitions. Obviously, we don't have any. We create our first job stream based on this workflow, using the last task as the target job. We simply type part of the job name. This is important, as you can see that job exists as a task in many other workflows. It's not common in production, but it can be done. It's important to select the right one. We select the one associated with the workflow we showed earlier. On the left, you can see the number of jobs in the workflow. No number means no parents. This happens because the individual job was imported as an object, but also as a workflow task. If you select this, you'll create a job stream for an individual job, which doesn't make any sense. When you select it, it tells you the number of executions imported into the AAI database. By default, the name of the job stream is set to the name of the task. We recommend using something more descriptive. We'll confirm, then create more job streams and let the system run for a few hours. We're obviously going to skip this step. We've created a handful of job streams and let the system run on its own for a few hours. This is the results. We're in the dashboard. Let's expand the job stream menu. The job stream menu contains our definitions. The grid offers a representation of operations in a table. The timeline offers the same information, but as individual lines over a graphical timeline. This is the list of job streams we created. Information pertaining to this job stream is shown. Scheduler, target job, parents, number of jobs in the job stream, the last start time, as well as the business area, which is really a way to categorize our job streams. For example, if you want to filter logistics, finance, sales, operations, and so forth. This way, department heads can focus on their own jobs, say analyze only finance, without seeing other processes. The grid consolidates job stream runs selected based on a filter. You can change this value if, for example, you wanted to focus on a set of job stream runs for the last week. The default value is current, last 24 hours to next 24 hours, of course, because AI offers predictive analytics. You can also see the status in Automic, running, completed, failed, and so forth. Finally, you see the SLA status, on time, late, or even predicted status. For example, if a process is likely to fail to meet its SLA. Not only can you take appropriate steps to warn the relevant stakeholders of the upcoming missed SLA, but you can also try and troubleshoot, optimize the process in Automic, and prevent future SLA failures. This is one of the key benefits of AI. This is the timeline, which shows a series of boxes of different colors evolving over time. There's a double filter, time but also category based on business area. Last 3 days, show only logistics. Of course, you can change these. For each job stream, you see a number of job stream runs, which should match executions for the period in Automic, status, and so forth. We see our inventory job stream, which we used as an example in the introduction at the beginning. These are all the runs for the period shown above. We can select any of these to obtain more information about that particular run. We see the jobs in the workflow and run details in the right panel. This is the graphical representation of the job stream run, which gives you a good idea of the runtime of each component job. The critical path represented by the red lines between each job, the average end time, and the SLA time. You can place the mouse over each individual job to see the details, such as the Automic run ID.